Hello, everyone. Thank you for joining Pipeline Templating, enabling DevSecOps adoption across the enterprise. My name is Stephen Terrana. I'm a chief engineer at Booz Allen Hamilton. And today we're going to talk about an approach for implementing large-scale DevSecOps pipelines. If you're like me and you've worked on implementing pipelines for multiple teams at the same time, you found that it's really challenging. And the reason it's challenging is because different teams use different tools, and all the CI tools in the industry are really focused on how to implement CI/CD pipelines for a single application. So you'll have a Jenkins file in every source code repository or a GitLab file in each repository, and you end up copying and pasting that for different teams. There's some work you can do around shared libraries to try to consolidate code, but at the end of the day, you have multiple source code repositories. So today we're going to talk about how the Jenkins Templating Engine allows you to implement a single tool-agnostic pipeline template that you can share across teams. And we're going to do that purely through a live demonstration. So there's no slides that accompany this. We've got VS Code and a browser, and we're going to dive right in. So first things first, we need to get our local development environment set up. So I've got a just file. This just file has a couple helper scripts. It's going to build a Docker or a container image that's using Jenkins LTS. It uses Jenkins configuration as code to configure the Jenkins instance. And we've got some other helpful automation in here. So I want to get right to the demo, but if you're interested, all of this is available online in a GitHub repository that I will share the link to. So let's kick things off. I can run just launch Jenkins. That's going to pull the latest LTS image and build that custom container image for us. That's going to make Jenkins available on localhost 8080. So if we switch over to a browser here and go to 8080, we'll see that Jenkins is about to start up. There we go. So while Jenkins comes up, let's go back to a browser. So the way this local demo works is we're going to have what are called libraries. These libraries live locally. They're mounted to the container image so that as we make changes to this local directory, Jenkins is automatically able to pick up those changes. Within the just file, we have a just watch recipe that uses watch exec so that every time we make a change to a Groovy file, it's automatically going to commit that to this local Git repository. So if I run just watch, we're now watching and changes are automatically going to get picked up. Going back to our browser here, see that Jenkins is now up and running. First things first is we need to create a pipeline job. So we're going to stick with a pretty basic demonstration just to get the concepts of JTE across. The simplest way to make a JTE pipeline is to create a regular old pipeline job. JTE does support consolidated pipeline templates for GitHub organization folders or multi-branch projects. But using the ad hoc pipeline job is probably the fastest way to get up and running for a demo. Let's make this a little bit bigger. So if you have used Jenkins before, you'll be used to seeing the pipeline script and the pipeline script from SCM. When you install JTE, it adds a new option called Jenkins Templating Engine. We can define two artifacts right from the console. One is called a pipeline template, and one is called a pipeline configuration. So the whole theory behind the Jenkins Templating Engine is that it allows you to decouple the business process of your pipeline, what should happen and when, and what are the steps, to the different tools that might be used across an organization to implement those steps, right? So before we dive into how JTE does templating, the first thing to understand is that a pipeline template in JTE is just a pipeline, just a regular old Jenkins file. So there's nothing stopping you from writing some pipeline code that you may be used to. So we can just say echo hi world, and we don't need a pipeline configuration because we haven't loaded anything into this template. So we can click save, and just to prove that this is exactly like any other Jenkins file. We'll run this build, and we'll see that it in fact does pass. So JTE does support declarative pipeline syntax. For today, we're going to stick to scripted pipeline syntax, and I'll show you why. So let's say we wanted to create a pipeline template that does a build. This might be a build from Maven, this might be a build from NPM, Gradle, Docker. There's all these different build tools for different types of applications, and traditionally, that would mean writing a new pipeline, right, for each of those applications. So you might do something clever like have a global library that has different implementations, and you have to import that library and then call a common entry point. But you still have to duplicate your pipeline definition and make some tweaks across every repository to make it work. So let's show how our very first pipeline step, we can create a build. So alongside that pipeline template comes the pipeline configuration file. In the JTE 201 video, we can talk about how these pipeline configurations are actually hierarchical. You can create a Jenkins-wide pipeline configuration for JTE and then add configurations onto specific folders, all the way down to individual application source code repositories. So you can create governance hierarchies in JTE that are as complex as your organizational hierarchies. And there's some rules around how those pipeline configurations are aggregated. For the sake of today's demonstration, we're going to stick with a common or a single pipeline configuration. So we wrote a template here that says build. So now we need to actually make that mean something. So in our pipeline configuration, we can create a libraries block. Just to note, this pipeline configuration syntax is just a custom Groovy DSL that looks a lot like a blocked nested structure here. So we can create a libraries block, and let's say that our team is using Maven. So we can save that and we can run it. And right now that's going to fail, and it's going to fail because we haven't actually gone and created a Maven library. So just to prove that, we get some errors. The Maven library hasn't been found. So let's create it. If we head over to VS Code, there's a nice helper function here in our just file where we can say just create Maven. And that's going to create a new directory for us within the libraries directory called Maven. Every library in JTE has 3 main steps to it. You've got a resources directory, a source directory, and a steps directory. So the resources directory is where you can stash files that you want your steps to be able to consume, things like shell scripts or Python scripts or JSON files or what have you. The source directory is where you would define classes. There's some use cases where being able to have classes is very useful. For today, we're going to live in this steps directory. So back in our template, we said that we needed a build step, and we were going to use the Maven library to do that. So I can create a new file and call it build.groovy. The base name of the file is going to be the name of the step that gets loaded. Within this build.groovy file, we can implement a call method, and we can say println building from Maven, right? And we saved that, the file watcher that's running in the background, committed it to the local repository, and now it's already accessible to Jenkins. So if we rebuild this Jenkins job, we'll see that JTE tells you everything that it does. So you can see all the pipeline configurations that are added. We'll see that we loaded a Maven library. There's a warning here because the method build is actually a Jenkins step. So JTE lets you know that you've created a library step that's going to override a default, regular old pipeline step. And then at the bottom, we'll see that JTE puts out a log message that says we're about to implement the build step from the Maven library, and then we have the functionality that we expected to see. So a quick note on why is it a call method? So that's just Groovy syntactic sugar. So in Groovy, when I say build, that's equivalent to saying build.call. So I like to take away as much of the magic as possible. There's nothing special about a call method besides the fact that it's some syntactic sugar in Groovy that allows us to use the shorthand notation for invoking the step. So let's say we had another team, and that team was using Gradle, for example. So let's save these file contents, and let's create a new Gradle library. So we can say just create Gradle. It's going to spit out a new directory. Inside the steps directory, we also want to implement a build step. So we can paste the same code in here and say that we're building from Gradle. So if we go on back to Jenkins, if we wanted to use the exact same pipeline template, which traditionally would be stored in a central source code repository and inherited by multiple teams, you would not have to touch this pipeline template to apply it to different teams using different tech stacks. This pipeline template that you create essentially defines an API, interface between the template and the libraries. So one team could have a pipeline configuration that uses Maven, and the Maven build step is going to be used in this template. But another team could come in here and all they would have to specify is that they're using Gradle. So without changing this template at all, which is common across multiple teams, and just specifying a different library being loaded, we can now rebuild this pipeline. And as you might expect, it loads the build step from Gradle, and we get different functionality. So that might seem pretty trivial, right? Because we've got 4 lines of code total here, and we created 2 pretty small files. But the idea is pretty huge, right? I've been on teams before JTE existed, where there were something like 50 or 60 different microservices that each had their own source code repository. And making a change to the pipeline would mean opening pull requests to every single source code repository, trying to orchestrate those changes with the development teams, sort of tweaking those pipelines for the different tech stacks. And what JTE allows you to do, and what we just demonstrated, is taking that Jenkins file from every source code repository, making it tool agnostic, and defining it in a central location. So all that needs to be defined in each source code repository are the aspects of the pipeline configuration that are unique to that team. Because of the hierarchical nature of the pipeline configurations, common controls like which libraries to use if they don't change between teams, things like container image scanning that have to be consistent across everyone. You really have the flexibility to control what pipeline configurations are governed and what pipeline configurations can individual teams update. So let's dive into a couple more features that JTE has to offer. So these libraries are only as valuable as they are reusable. So different teams are going to have different versions of Gradle. They're going to have different code quality thresholds. Maybe they don't want to enforce unit tests. There's all these nuance to how you would want a pipeline to work for a given team. So the way JTE allows you to handle that is to pass in library configurations. So in this example, we can assume that the Gradle library for some reason takes in a message field. We're going to say, hey, from Gradle. So if I'm a library developer and I want to consume that library parameter that's been passed in, we can say the message is, and now we can access this config variable. And this config variable is auto-wired to the steps at execution, and they have access to the library configurations. So I can say config.message and save this, head back on over to Jenkins, rebuild it, and we'll see that when the pipeline runs, it's able to consume those library parameters. So those can range from anything from what version of Gradle am I using to what are the targets that we want to execute. Is it Gradle clean package, Gradle clean verify, test, what have you. So an important thing to understand is that libraries and steps do not define method parameters, right? And the reason that they don't define method parameters is because, going back to our template for a second, if we had passed to the build step, hi from Gradle, now every single step implementation of build across all the libraries would be expected to consume a string parameter, right? So the reason these library parameters are so helpful is because it maintains the interoperability of the templates. We can just call a build. These builds don't take parameters across all the different implementations, whether it's npm, Maven, Gradle, what have you, and we're able to pass that information in the pipeline configuration file instead. So another neat thing that you can do in JTE is define application environments. So the one exception to the rule for not passing in parameters is when you want to create a deployment step. So let's have our template say deploy to dev and deploy to test. And let's assume that we're going to create an Ansible library that's going to handle that deployment. So this dev variable and this test variable are going to come from the application environments block. So I can define a dev application environment and a test application environment. Inside the dev environment, I can define whatever environmental context I need to be able to do deployments to different environments. So maybe I have a different Kubernetes cluster for every single application environment. For our dummy example, let's assume that Ansible expects there to be an IP addresses array where we can specify a couple IP addresses. We'll do the same thing for the test environment. All right, and now let's go create that Ansible library. So we'll save this configuration. We'll head on over to VS Code. We'll say just create Ansible. Inside our template, we had created a deploy to step. So we're going to create a deploy to.groovy file inside the steps directory. We're going to say void call, and we're going to take in an application environment. And now I can say appenv.ipaddresses.each, and we can print out the application environments, print ln, deploying to IP. All right, and let's also add a stage just to be able to visualize the deployment that's happening. So I can say deploy to appenv.longname. So application environments have a couple fields on them that let you differentiate which application environment you're talking about. So here we've got our steps. I can save this. We can head on over to Jenkins and we can give this a run. So here we can see that the Gradle step happened. We've got a message from the JTE framework that says that the deploy to step from the Ansible library is about to be executed. We have our deploy to dev stage where we're using the IP addresses from that dev application environment. And we have the test phase where we're doing a deployment to this test with these, the test configurations. So these dev and test variables and these steps are examples of what JTE calls pipeline primitives. So pipeline primitives are just things that you can define from your pipeline configuration that automatically get created and injected into the pipeline runtime. And that's really how templating is enabled. So we said at the beginning that these pipeline templates are just Jenkins files, and that's true. But what enables the templating is the fact that prior to execution, JTE parses your pipeline configurations, it loads the libraries and creates the steps, and it looks for any other pipeline primitives that have been created, and it injects them into the runtime. So there's actually an object called build and an object called deploy to in dev, and that's how templating is enabled. So there's a couple other primitives that you can create that we may not have time to get into today. So there's things like stages where you could group multiple steps together to keep your templates dry. So under stages, I could say that there's a CI phase that does unit test, it does static code analysis, and it does a build. And then up in your pipeline template, you could just say CI, and that's going to kick off these 3 steps. And that's really just to keep the templates as easy to read as possible. Another primitive that exists is keywords. So keywords are a way to inject variables into your pipeline templates. So a common use case that I use keywords for is to define regular expressions for branch names if you need to do some branch name validation or conditional logic based on branch names. You can also use keywords for defining globals. So here we could just define that there's going to be a keyword called banana that's equal to 11. And we could define a globals block that's going to have variables A, let's call that 12, B is true, and C is A, B, C. So now there's going to be a variable accessible to the pipeline template called globals and banana. So I can say println banana because it's just going to inject the variable name, and I can say println globals.a, globals.b, and globals.c. And let's just show that that is in fact going to be accessible. So here at the bottom, we've got the value that we had for banana, the value that we had for globals.a, .b, and .c. So these template primitives are there to make your templates as easy to read and to write as possible. So let's go over one more feature that JTE has to offer today, and that's called, we call them lifecycle hooks. So let's talk about a use case where, let's say I wanted to send Slack notifications. You wouldn't want to hard code your Slack logic into every other library that you have. You know, that kind of defeats the purpose of being able to plug and play with these different steps that exist. So JT's approach to solving that is what we call lifecycle hooks. So let's create a Slack library. You know, we are not going to update the template at all, but we're going to see a way that we can add Slack notifications, you know, dummy Slack notifications at different phases of the pipeline automatically. So we can save this configuration. We can go back to VS Code. We can create a Slack library. And we can create a step called hooks.groovy. And this file can be called anything you want it to because we're not actually invoking it directly from the template. Instead, what we're going to do is utilize these special annotations that JTE has. Let me create them and then I'll explain them real quick. So there's a couple different options that are available. There's init, which runs at the beginning of your pipeline. There's before step and after step. There's cleanup, and there's notify. So let's finish creating these methods at notify. And we can add some print statements to all of them. Print ln init. And let's add one for before. Let's add one for after. Let's add one for cleanup. And let's add one for notify. And then let's run the pipeline again. Let's head back to our browser. And just to refresh, didn't add anything inside the pipeline template. All we had to do was load the Slack library, which has these hooks. And when we run the pipeline, so that's a fun bug. Let's run back. So you can't actually implement a method called notify. It's a reserved method. So if we look at the error that we got, you're not allowed to override the final message notify on the object class. So that's easy enough to fix. We can say notify hook, and now that will work as expected. So we rerun this job again, and we'll see that these messages from our hooks are getting printed out at a lot of key places. So again, JTE will tell you what it's doing as it does it, right? One of the honest drawbacks to JTE is you have code coming from a lot of different places. So to facilitate troubleshooting and debugging, these messages make that really helpful to figure out where is this output coming from. So here we can see that there's an init annotation that's going to run the init method on the hook step from the Slack library, and it just prints out the message. And now for each step that we run, we've got the before step, the step itself, and then the after step, and then the notify hook. So visualizing this can get kind of tricky, so let's go take a look at the JTE documentation. And under library development, we can look at lifecycle hooks. Let me zoom in a bit to make this easier to read. So here's a picture that sort of, my face is blocking it. Here's a picture that sort of shows the way that hooks run as part of the pipeline. So in the beginning, you've got a validate annotation and an init annotation. For every single step that gets executed, you've got a before step, an after step, and a notify. And then at the end, you have cleanup and notify again. Sometimes you might not want to execute every hook before and after every single step. So if we look at the documentation, there's something called conditional execution where you can pass a closure to these annotations, and the return value of the closure is going to be used to determine whether or not the hook should be executed. So we're coming up on time, but lifecycle hooks are one of my personal favorite features that I love to share. They're really helpful for things like notifications, for sending pipeline metrics to something like Splunk or Elasticsearch so that you can visualize them in Grafana. Hooks come up in all kinds of fun ways. So the library development documentation will actually show you all the features that JTE has to offer. So when you parameterize libraries, there's functionality around library configuration files. They'll let you do some type validation on your library parameters. Here's an example of how I would recommend documenting these libraries. So at Booz Allen, we have pipeline libraries that exist. Every single library that we have has a README that allows you to see, let's pick on SonarQube, allows you to see what are the library steps that are contributed when you load the library, and what are all of the configuration options for that library. There's also a newish repository called JTE Library Scaffold that sort of helps you get off on the right foot when it comes to starting your libraries. So this repository integrates with release management. We use Release Drafter for release notes, unit test for the libraries through Jenkins Spock, npm Groovy lint for linting. It updates the library structure a bit so that every single library that you have can have a README file. So within each library, you create a test directory for your unit tests. You can add a README for the library documentation. Here's an example of that library structure. And this repository is a way to automatically integrate those library READMEs into a nice user-facing library documentation site so that you can communicate with your users what are the libraries available and the steps that they can contribute so that you can build sort of a pipeline as a service framework so that folks can configure their libraries using your building blocks instead of having to write them all from scratch. So feel free to check this out. Feel free to let me know if there's any feedback. I'd love to talk about the different use cases. So to summarize, the Jenkins Templating Engine is a pipeline framework. It allows you to create tool-agnostic pipeline templates that can be reused across as many teams as you want simultaneously. You no longer have to create a new Jenkins file for every source code repository. Instead, you can define that common template and then share common configurations, but also allow teams to specify what's unique to them, right? So the takeaway here is that it's a simpler way to manage large-scale DevSecOps pipeline adoption across the enterprise while having enhanced pipeline governance, right? You don't have to go double check that every pipeline is implementing what you thought it should. So these templates really allow you to define as an organization what are the required steps of your software delivery process, and then give you a mechanism to implement that while still giving teams the flexibility they need to choose the right tools for the job. So feel free to join the JTE Gitter channel. We'd love to hear from you. Feel free to star the JTE repo and open an issue. We love to hear from our end users. Thank you for taking the time to talk today. Bye-bye.